So first we talk about this two-way ANOVA. That means you have two factors you are interested in. Okay? So for this one, say the chemical engineer studied the effect of the two factors, reagents and the catalyst. Okay? So for this one, the catalyst, see how many different levels. We have A, B, C, D, 4 levels. And for the reagent, we have 1 to 3 levels. Okay. So this is the ANOVA table for the two factors. So next, we just put the data into the, so we copy the data. So yeah, you can follow me if you have the file, just Control-C, and then we, like we did with the one-way ANOVA. So we have two factors. So the very first thing, you check the type of variables, okay? You look at, since a reagent, then it's numbered 1, 2, 3, level 1, 2, 3. So JMP automatically think it's a numerical variable, but it's not. So I need to change to categorical. Okay? So this is, sometimes you didn't get the results, it's just because during this copy-paste process, it's lost the, it's changed the type of variable. So now we have two categorical variable, that's the input, and one quantitative, that's the response output, that's your Y. And then analyze the fit model. It's like one-way ANOVA. We put the yield, that's your response put on Y. And this block, that's where you put all your inputs. So we put catalyst, we add this one, we add another factor. So the interaction, also a factor we need to add in. So we need to select both. You use shift, you select both, and use cross. Okay? That means we put the interaction as a separate term into your model. You just select both factor and click cross. So see, this model, you have 3 terms, 2 factors plus the interaction of the 2 factors. Question?
Do you just put catalyst times reagent?
You don't time. You just select both catalyst and reagent. You use the shift, select all, and then you click cross. Now you have 3 terms, and then you just run the model. So this is the result. So say analysis of variance. So one part is the model part, have 3 terms. So the F ratio is 3.96. The p-value is very small. So that means the model is significant. So next, in the effect test, just give the individual the p-value for each factor. Okay. For catalyst, see the p-value is very small. Reagent is very small, both significant, but the interaction is not significant. Okay. So in this case, since the interaction not significant, we can put together as arrow point. So we can go back to do this ANOVA again, but this time only have 2 significant, the 2 factors. There's no interaction because we go through the interaction as a term, found out it's not significant. So we put into the arrow part. So we go back to our data, we do the analysis. So this time, yield, so it's a response variable, and these 2 as factor. Since we know the interaction not significant. So what we have, so this time the effect, so catalyst reagent, see still both significant if alpha is 0.01. Okay. So are we done? Okay. So we need to check assumption. Right? So certainly the same procedure. We check the assumption. You see this one residual by predicted plot. Let's copy this. So this just shows constant variance, okay? And also we can plot the residual on the normal plot. Normal. So it's under a row diagnostic, yeah, has the residual by normal quantiles. So here is the residual. So we see it's under the, you click this, yeah, row diagnose. It can plot, it also can plot the residual by row. Okay. The residual by normal quantiles. So we come back to see this is the, yeah, normal plot, yeah, approximately normal, the residual. So we still need to go through the test. And once, since we find it significant, still the similar approach, we need to see which one are significant. So which level is significant, we still use the Fisher student t-test or 2-key test. Okay. And then we find out what are different, see. So what we found out, they have 4 levels for catalyst. So certainly catalyst A is significantly higher than others. You're welcome. So for reagent, that's the same thing. You can, yeah, these two are popularly used. Okay. So they have the same result. Excuse me. So for the level, seems level 2 and 3 significantly higher yield than level 1. Okay, so this is your conclusion. Okay, so that's the whole process of two-way ANOVA. If you have 2 factors. So another factor, but we know there are some other factors that impact your response value. I'm not interested in, but I need to do the control. So we listed this one as a factor. So the block factors a lot of times involves, see, your material batches, okay, and your operator. For example, if you do find out, say, your material interaction, that means this material, not you want, there's something, some chemicals affect your, say, your cutting tool or your reagent. Like operators, normally the operator shouldn't have the interaction. Equipment and time shift. If there is interaction, certainly that's a quality concern. You really need to do investigate. So these factors we are not interested in, but we know its impact on our result. So we need to take the values come from it, take that out. Okay. So blocking, that's just a strategy used to control this type of factors. So when you analyze, that's the same as two-way ANOVA, two-factor ANOVA, without interaction. So this is our data here. Sprinkler locations. Again, location, since we list as 1 to 3, so JMP considers as a numerical variable, we need to change to categorical, nominal. Okay. So now, so input 2 categorical, 1 response variable is quantitative. So we go to analyze and fix model. So efficiency, that's the response. Always response is Y. We put on the top Y. And then this block, we put the factors because we add these 2 factors. Okay. Since we know location is a block, so we do not add this interaction part. So only 2 terms we run. So the model part is significant. Okay. We look at the specific, this F ratio and the p-value. Say sprinkler, F ratio 4.6, location 6.1. So which is have more impact on this on this efficiency. Which one has more impact? Location, since F ratio, so the variation comes from location, it's 6.1 times of the error part. But the variation comes from sprinkler only 4.6 times. See, if location we do not take out as the block, certainly you cannot tell the difference, the sprinkler. So we can do give you the idea. So sometimes you just forget, you don't know that will have impact. What would happen? Okay. See, this is our data. So in that case, we only interested, see, only sprinkler have the impact. Suppose we don't know the location have the impact, and we run the model. So so if you only listed the sprinkler as the main factor, one-way ANOVA, see the p-value is 0.47. It's so large. So your conclusion will be sprinkler make no difference. So because your error part is so large, you look at if you separate that location as the block, the error part down to 2.96. Okay? If without that block, the error part is 19.4. It's like the location causing the variation. You all put into the noise, into the error. So you cannot tell the difference among sprinkler. But now, if you use the block, see, use the same location as another factor, as a block, you find out. So this is the effect of sprinkler. This is the effect of location. Still, sprinkler is significant. So how we can find out that there are some hidden variables, hidden factors we should consider, but we forget. What we can find out? We can find out from the residual. You see, for this one, if we plot residual, see, we see let me see, maybe there are some diagnosed residual, plot the residual by row. I'll have to save the residual and plot. We save the residual, save residuals. So this is residual from one-way ANOVA. We only consider one factor. So this time we go to our data. So we have one column called residual, and then we just plot, see, the residual as y-axis, and then to see location. So what you find out? You plot residual, for a test, you plot the residual with any factors you think, you suspect may have impact on the response variable. It should be no pattern. Now you found out the pattern, right? The location 1 certainly have higher efficiency. The location 3, the lower efficiency. That means location impact has you don't know it's significant or not yet, but certainly impact your decision. Impact to your response variable. So this time you need to bring in as a block, as another factor, and then reconduct ANOVA. And then you can tell the sprinkler, the real factor you are interested is significant. So that's okay, so we are done with this part.